Hello, let's look at this paper, which is the natural sciences for grade 7, okay, end of year examination, okay. This paper is supposed to be written or was supposed to be done on the 14th of November, 2025. Okay, so it's a district paper out of 80 marks. Let's dive into the paper. So for those that have not yet written, feel free to use it as a revision guide. For those that have written, let's assume it's a proposed memorandum. All right, fill in the missing words in the paragraph using the words in the table provided below. Write these words or write the words you have selected in the spaces provided below the paragraph. Okay, so the first word is coal, used up, non-renewable, environmental, renewable, water, expensive, as well as wind. And so the first paragraph tells us that there are two types of energy. Okay, number one, we have what we call the renewable. Okay, and then 1.2, we have the non-renewable. Okay, energy that can be renewed and that the other one that cannot be renewed. Alternatively, you can switch them around. There's no problem. Okay, then energy sources like that gas and oil are called non-renewable energy sources because they will eventually all be blah, 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 blah. So of all of these, which one is an energy source? It's basically coal, okay? So energy sources like coal, gas, oil are called non-renewable because they will eventually all be finished or used up. So used up is the best word there. So used up. And then these energy sources can create some problems, which problems are environmental, okay? So environmental problems. And then energy is also dash, so we need to use it wisely. What does this mean? Energy is also expensive. Okay, when something is expensive, you need to use it sparingly before, it gets wasted. So renewable energy sources like, which ones are renewable? It's wind. Okay, like wind energy and energy from falling water will not be used up. So the answers here, okay, so for 1.1, we said we can say renewable or non-renewable. And then here it will be the non-renewable or the other way around, depending on how you started. Okay, so this is coal, this is used up, this is environmental. Okay, we say this is expensive. And then lastly, we have the wind. All right, then question 2, match the following words in column A with their meaning in column B. Write only the letter that is representing the correct answer within the answer grid. Okay, so we have joules, we have input, output, energy system, process, biological system, mechanical system. Okay, so 7 questions, 7 answers. Okay, so what we have here is that the outcome of the interaction and the system, pair of scissors, cutting a piece of paper, energy before any interaction occur, how energy is changed, measurement of energy, different parts that work together for a specific task, and then a cat that is drinking milk. So let's start with joules. Okay, we know that joules is basically a measure of energy. So how energy, or the measurement of energy. So we're going to have E for 2.1. And then when it comes to the input, we know this is the energy before any interactions occur, okay? It's what you're starting with. So energy before interactions occur, that will be the best choice there, okay? And then 2.3, the output, this is the energy after or the outcome of the interaction. I'll have the A there. And then the energy system, what is an energy system? This is basically the different parts that work together for a specific task. So that's going to be our F. And then 2.5, what is a process? A process. So we've looked at A, we've taken out F, okay? So we can have the next one to be how energy is changed because that's a process, okay? And then a biological system. a biological system. Which one is a biological system? So it has to be G. When a cat is drinking milk, that's a biological system. And then whatever is left has to be a biomechanical system, pair of scissors, cutting. So that is our B. All right, then section B, the sources of energy. They're telling us that the image shows a pot of water that is heated over a fire. 3 examples of heat transfer are shown below. Okay, so we know that with those heat processes, we have what we call the convection, we have what we call the radiation, and then we also have what we call the conduction. Those are the energy sources or the energy transfers. Okay, so let's see. They want us to label each heat transfer correctly. So when the heat moves from the wood to the pot, okay, so that is going to be radiation. The heat is radiated, the heat is moved. Okay, radiation. And then when the heat moves from the pot to the water, okay, from the pot to the water, that's going to be convection. And then, or basically from the water into steam or whatever is happening inside that pot. And then when the heat moves from the pot to the man or to the person that is handling the pot, that's going to be conduction. That's going to be conduction, transfer from one point to another. So this could also be like energy transfers within the different phases like solids, liquids, and gases. So when heat moves from a solid via the air, that's what we call radiation. When it's moving within the liquids, that's convection, and then from solids or in between solids, that's the conduction. And then 3.4, use the flow diagram provided to write a paragraph, okay? The paragraph of 5 to 6 sentences to explain why you agree or disagree with the statement. Use the words in the text box in your explanation. Okay, so a boy says, the energy I get from eating a slice of bread is a result of the sun shining on earth. Do you agree or disagree? So the words we have to use is capture, photosynthesis, release, sun, store, wheat, energy, bread. Okay, so what do we need to say here? Okay, so number 1, we need to agree. Okay, that is true, because this is a process. Okay, so what we can say is that the sun's energy, okay, the sun's energy is captured through a process called photosynthesis. Okay, we know that this is a process where green plants make their own food. Ne? Then we're saying that wheat plants use the energy to form or to create what we call the carbohydrates, which they store. They store the carbohydrates in their wheat. We call them the wheat kernels. Okay, and then we are saying that the wheat kernels, what happens to the wheat kernels? The wheat kernels are grounded. Okay, they are ground to make. To ground is like to squeeze out or splash out or take out to make what we call the flour. To make the flour, which is used for sinkwa, which is bread. Ne? And then the sun's energy, therefore, is captured in the carbohydrates that are found in the wheat. The carbohydrates. So when the boy eats the bread, what happens? The energy from the carbohydrates will be released. So something of the sort is what they needed, okay? There are certain keywords for as long as you make use of the words that you were given. So one other thing that we need to also remember is that energy can never be created, nor can it be lost. It just changes from one form to another. Now there was the sun with its energy transferring it into the plants, and now someone eats bread, and then that energy is being transferred into the person. All right, then 3.5. The following image shows the nutritional information on a box of cracker biscuits, okay? We have the energy, we have the protein, and so on and so forth. Then what is the energy content per 100 grams in joules? So the energy content we are seeing is 1492 kilojoules, okay? 19, that's 1492 kilojoules, but they want it in joules, meaning that we need to multiply this by 1,000. So it's 1492,000 joules. Okay, then what is the mass of 3 biscuits? So they're telling us that 2 biscuits are an equivalent of 15 grams. Okay, so if 2 biscuits are 15 grams, meaning that 1 biscuit is going to be 7.5 grams. Now we're talking of 3 biscuits, that's gonna be 15 grams plus a 7.5, which gives us a 22.5 grams. Okay, so that's how I would have worked it out. So it's a 22.5. How we got it? We said 15 divided by 2. You multiply by 3 if you want, then you get back to that. Then 3.5.3. They're telling us that the nutritional information gives energy content if the serving size is 2 biscuits. But if you want to know what the energy content will be if you eat 3 biscuits, they want us to calculate the answer. Okay, so if, okay, the energy for 2 biscuits is 1492, how about 1 serving or 1 biscuit? What do we do? So is it true that we can do the division again and say that 1492 divided by 2, they're asking for? If you want to know what energy content, if you eat 3 biscuits, that is not making sense. Okay, this is per 100 grams, no? But if we are talking of energy per 2 servings, we're having 224, okay, if for 2 people or for 2 biscuits. So if it is 224 divided by 2, which becomes a 112, and then if I multiply that by 3, I'm going to end up with a 336. So 224 divided by 2, which gives me 112 per biscuit. Okay. And since we are focusing on 3 biscuits times 3, which becomes 336, this is kilojoules. All right, then you then decide that you want to eat 6 biscuits. What's the energy content for serving 6 biscuits? So we know that 6 is twice of 3. Okay, so it's going to be like 336 multiplied by 2. That's going to be 672 kilojoules. All right, question number 4 is a case study about the solar energy. They are telling us that South Africa is a sunny country. However, because the sun does not shine at night. Scientists have had to find ways to store the sun's energy so that it can be used at times when the sun is not shining. In a concentrated solar power plant like the one shown in the picture below, thousands of mirrors focus the sun's rays to the power tower in the center. Here, the sun's energy hits a type of salt to about 565. The molten salt is used to heat water, which produces steam to generate electricity, as in a normal power station. Some of the hot molten salt is stored in a storage tank underground. At night and in cloud weather, the stored molten salt is used to keep the power station going. Okay, 4.1. Briefly explain the law of conservation of energy. So we know that energy, okay, we're saying energy cannot be created, okay, or energy cannot be destroyed. Okay, but what happens to the energy? It just moves from one form to another. So energy is transferred, okay, from one form, or we can say from one system to another system. Okay, then 4.2, name 4 types of renewable energy and provide an explanation for each source. So the first one we can think of is basically the solar. And then we know that solar panels are used to do what? To absorb the radiant energy from the sun. Radiant energy from the sun, okay? And then transform the energy of the sun into stored potential energy, okay? We are saying, and then transform it into the stored potential energy. Okay, that is source number 1. Source number 2 that I can think of is the biofuels, okay? Biofuels, what are they? If we have crops like maize, okay, the mealie plants, we have the soybeans. Soybeans are fermented. Okay, they are fermented so that the sugars transform the energy. Okay, they transform the energy into what we call the ethanol. Okay, ethanol, which is more like some bit of alcohol. Then we also have what we call the hydro. Hydro is where we use the water. Ne? So we are saying hydro water, which is, so we can say that water is stored in a dam. Water is stored in a dam and can run through a channel. It can run through a channel where it turns a turbine. Where it turns a turbine. Okay, and then number 4, we can have what we call the wind energy. So we are saying that this is energy from moving particles used to also turn what we call the turbines. Okay, then 4.3, explain why energy mentioned, or the energy mentioned in 4.2 is regarded as renewable. So number 1, we can say that this energy is naturally stored. We can store it naturally. Okay. And then number 2, it can be replaced. It can be replaced. Use it and then again you reuse it over and over again. All right, 5, draw an energy flow diagram in the block provided below and explain the input, process, as well as the output. So what we see is that the input, what happens with the input? We have what we call the store of chemical potential energy. Now that is happening within the cell or the battery. And then the process is going to be transfer. The energy is transferred as electrical energy, and then the output is that we get what we call the light energy. So chemical energy in the battery or the cell transferred as electrical energy, and then we get the light energy as our final output. Then explain briefly how heat is transferred by, number one, conduction. So we said conduction is basically the transfer of heat between, or we can say that from one object to another object. And remember what we said earlier on is that this normally works under the solids. And then radiation. What is radiation? So it's basically the transfer of heat, okay, across an empty space. This is basically a transfer of heat within the gases. And then convection is basically heat transfer of heat from one place to another through a liquid or by movement of a liquid or gas particles. Okay, so that is that. And then 5.3, why can convection not occur? Why can convection not occur in the solids? So convection, we know that it normally happens in liquids or gases because there is basically free moving particles, okay, which is not the case with the solids. So we can say that the particles are tightly packed. Particles are tightly packed, so we don't have any free moving particles that can easily transfer the energy that fast. Then question number 6, complete the following table of energy systems. Write your answers in the spaces provided. Okay, we have the energy system. We have the example of this energy system, and then the type of energy that is used in the system. Okay, so which energy system is dealing with the kinetic energy and the riding of a bicycle? So the energy system is what we call the mechanical. Okay, and then sound energy with the radio, it uses what we call the electrical. And then if it's biological, you're eating a sandwich, this is going to be the chemical potential energy because chemistry is happening in your body. But the sandwich is going to be broken down and you'll get some energy. Okay, and then example of a hot bath. This is going to be like hot bath. This is going to be heat energy, no? Because when you're bathing with hot water, you feel the heat, okay? And then which energy system is that? This is what we call the thermal. So we're saying it's mechanical, electrical, chemical potential, we have thermal, and then we have what we call the heat energy. Okay, so that is question number 6. Section C, which is the planet Earth and beyond. Choose the correct option from the underlined words in each statement. Write your answers in the spaces provided. Okay, let's see. 7.1, objects of large mass extend more or less gravitational pull on each other than objects of the smaller masses. So when you look at this, if the object is of a more bigger mass, the force that will be exerted is basically going to be more. Okay. 7.2, the closer together or further apart two objects are, the greater the gravitational pull that they exert on each other. So it has to be closer, because if you're far apart, then the force is going to be really very weak. So this is close together. Okay. And then at this gravitational pull or rotation, keep the moon revolving around the Earth. So this is going to be the pull. Okay, it's because of that force of attraction and pull that must keep the moon rotating. So that's a pull. And then 7.4, we know that spring tides are experienced when the sun, Earth, and the moon are aligned with or at right angles to each other. So it's very hard for these three to be at right angles. So they have to be aligned with. Okay. And then 7.5, there's a high tide at the same place about every 12 or 6 hours. This has to be 12. So every 12 hours, we shall have a tide. So if it's 6 in the morning, then expect the next tide at 6 in the evening. Okay. Then on a beach, animals between the high and the low water levels must cope with dry conditions all the time, or wet conditions all the time, or periods of dry and wet conditions. What do we think? Correct answer should be periods of dry and wet conditions. Okay. So periods of dry and wet conditions. So remember, there are moments when times are tough, okay? So animals that live on the beach, there are times when the water level is really low, and then there are times when the water level is really high. So animals need to adapt. Okay, then the tilt of the Earth's axis means that we have seasons or day and night. It's basically seasons. Okay, so that is how question 7 was supposed to be answered. And then question number 8, use the following diagram to answer the questions, okay? Name each phase of the moon labeled A to D in the diagram above. So when you look at the first one, which is A, so at point A, this is basically the third quarter or 3/4 of the moon. And then when you look at B, we shall be able to see the full moon at B. And then at point C, it's going to be our first quarter. Okay. It's going to be our first quarter. And then point D, we're going to see the new moon. Okay, so we know how that is done. Then 8.2, explain why we cannot see the moon shining in the sky when it is at point D in the image. Okay, so when the moon is at point D, okay, at the point of the new moon, why can't we see it? So what we can see is that the alignment of the sun, the moon, as well as the earth leaves the side of the moon that faces the earth to be just dark. Okay. So if this is the earth and then the moon is somewhere here, so the sun will only shine around here. Whatever we can see there is just like an image or something. So we're saying that alignment of the sun, moon, and the earth, okay, leaves the side facing the earth, in darkness. It blocks off the moon, obstructs that light, because remember the moon is supposed to reflect. Okay, then explain why the solar energy will be more intense on the equator and less intense at the poles. So what this tells us is that number one, the sun hits what we call a smaller surface area at the equator. Okay, that is number one. Two, we know that the curve of the Earth, okay, the curve of the Earth means that the sunlight is spread over a wider area, as you move away from the equator. As you move away from the equator. Okay, then name the season, okay, when the northern hemisphere is tilted away from the sun. So when the northern hemisphere is away from the sun, then they'll have their winter, okay? When the southern hemisphere is tilted towards the sun, then they'll have their summer. Okay, and then 8.5, use the diagram below and answer the questions, okay? To the sun, to the moon, A, B, C, D. Explain why the tide is higher at B and D, okay? So we know that high tides and low tides will be caused. Explain why, okay? So high tides as well as the low tides are caused by the moon. That is number one. Two, the moon's gravitational force creates what we call a tidal force, okay? The force between the moon and it creates a tidal force. And then the tidal force causes the earth and the water to bulge out. So tidal force causes the water to bulge out on the side closest. The side that is closest to the moon. And the side farthest to the moon. Closest and then farthest. Okay, so what is the name given to the tides that occur when the earth, the sun, and the moon are aligned? Those are known as the spring tides. All right, so guys, that brings us to the end of this paper. Okay, thank you very much for following. I wish you all the best in your preparation. Let's meet when we meet. Bye-bye.